...45-minute-ish, a little bit longer, I'm going to be talking with you about citizen data science. So first of all, welcome to Global Azure 2021, an event from the community for the community. This is the Lüdinghausen event, kindly organized by Frank, Katrin, and Katrin. Who are the two other organizers?
Ben and Dirk.
So thank you for those as well, because they've done tremendous work in the background to coordinate all of this, having actually 3 stages, which is for a local group, I would say quite large amount of speakers coming together. So looking forward to present to you. As I said before, the talk today will be on citizen data science. My name is Henry. I'm working for Microsoft as an Azure specialist with a focus area on data services on Azure, part of which are the Azure Machine Learning Studio, which we're going to be talking about a little bit later. I've been with Microsoft the last about a year now. Before that, I spent almost 5 years with Oracle in the database business there, and dealing a little bit with the Oracle Cloud as well. So what are you going to expect for the next couple of days? So for the next 45 to 60 minutes. We're going to be talking a little bit about input. What is data science? Why data science? What is citizen data science in some definitions that you find online, my own personal definition, and then moving onwards to, and this is probably why you're all here, a small demonstration of Azure Machine Learning, and in particular the Azure Machine Learning Designer, and how you can go out and start your own machine learning models with little to no knowledge in coding effectively. That's what we're going to show you and how to do that. And then from there on onwards, hopefully, if you want to, become your own citizen data scientist for your company. So my main message today is this one. You might not think so, but you can actually do more than you think. When there's a topic coming up in technology in general, people oftentimes turn off quickly and think like, oh no, this is complicated and no, I can't do this. I had this with the students yesterday a little bit, that they were thinking, it's like, oh, maybe I need a specific background. Do I need to study computer science to do certain things? As my answer is no. Very simple. We live in a world that is constantly changing and moving forwards. So what does that mean? It means that knowledge can become quite outdated quickly, and to keep up with what is going on, it is helpful to just drive what Microsoft calls the growth mindset and just keep general curiosity and keep the idea alive throughout your career and through your life that there's probably new things you need to learn. And you can learn because they might not actually be as difficult as they are or as you think they are. So if you take only one thing away from that, from all of this talk today, and you forget everything else, remember this: you can do more than you think. So my first question to you guys, as a sort of quorum, how much data do you think is generated every year? Just unmute yourself, give me like maybe a size more than a number. What do you think?
Hundreds of petabytes.
More than thousands of petabytes.
Okay, yeah, thousands of petabytes, hundreds of petabytes. Anyone else a guess? You don't need to look it up. I will tell you the number. Okay, that wasn't too bad. So this is a forecast from Statista that they have done based on some other research. So we're currently looking for the year 2020 into the range of 59 zettabyte. And this means actually data information that is created, captured, copied, and consumed worldwide. While one has to be aware that a lot of data that is currently being created on a factor to, I think, 1 to 9, 1 to 10, depending on what IDC interpretation you take, is actually data that is interpreted and copied. So it's not necessary compared to newly unique generated data. So a huge amount of growth of data that we're seeing is copied data and connected data. That's happening in more and more instances. Now people will ask, okay, 1 zettabyte, how much is that actually? So I looked up a comparison, and if you take 1 terabyte in 1 kilometer, or the equalization between 1 terabyte is 1 kilometer, then it would give you, to achieve 1 zettabyte, 1,300 round trips Earth to the moon and back. So it's a huge amount of data. It's like I personally still can't imagine that, but I try to visualize it a little bit. There's visualizations online if you want to look it up, where you basically scroll how much this actually is. And if you look back, this is growing. So by 2024, we will be almost triple, 2.7 times the amount of data that we had in 2020. And this is just going to most likely continue. And this data, of course, is being collected and being worked with. And this shows why it is so important to actually think about this, because it's not only, of course, from a personal private standpoint that my own data is constantly being monitored and taken apart, and things being done with through example, my phone, or in other parts through video feeds. If we think about the City of London, which has lots of deployed cameras, or if we think about China, who has been starting to do a citizen scoring model based on behavioral characteristics, movements of people, and other things, where lots and lots of more data is being generated in forms of images and other parts. So it's not only classical data in the sense of something that rests in a database of customer data, but it's also all this kind of data basically while we move through our life. Plus, of course, the abundance of sensors in almost every machine. If you think about a car, I don't know how many sensors are in a typical modern car today. I didn't look it up, unfortunately. If someone wants to look it up while I'm talking, I would be curious to hear. But I'm sure Tesla has a massive amount of sensors. And that not only goes for cars, that goes for manufacturing. All of those producing constant streams of data that can be interpreted and used to do things. And this usage is what we want to look at with the field of data science. And here's my second question to you. What do you think, or what do you believe is data science? The reason why I'm asking this is similar when you ask people what is cloud. There will be different definitions of what it is. And I'm just curious to see, because there's different flavors and interpretation of what one can do. So what do you think, or how would you for yourself describe data science if you had to?
It's taking statistics to another level by adding computing.
Okay. Yeah. Okay. That's good. That's close to what I would call it. Other opinions?
I would say it's also about analyzing data.
Mm-hmm. Yeah. Okay. Yeah.
If you look at it very basically.
Mm-hmm. Yeah, that's good as well. Yeah, that's part of it as well. Someone else? So what we do have, I've taken one definition. As I said, there are many different ones. I worked with an American organization, the Birch Works. They do reports once a year about for income levels. In this case, they had a specific work study in August 2020 on data in the field of data science. And they have given multiple definitions. What they started with is the overall group of predictive analytics professionals. They call them PAPs. And they define them as those that apply sophisticated quantitative skills to data describing transactions, interactions, or other behaviors to drive insight and prescribe actions. So this is a larger group. And of this group, there's a subset of professionals that we could call data scientists. Part of this group, for example, would be your classical business intelligence analyst. There would be your financial analyst. A controller could be seen as this result. Basically, anyone who works with some form of data, oftentimes nowadays still typically with Excel or sometimes even with a data visualization tool, Power BI, Tableau, one of those, Click, if you take those. But in general, they are those that are trying to use data, for example, historical data or business data that is already being generated to inform, for example, the business decision makers. So, for example, the owner of a company or the board of directors, based on what is happening and trying to use this data to generate insight for future action. A classical example would be, sales planning for a new fiscal year if you're stock traded, where you would, for example, use historical data based on this historical data of the last couple of years, a certain growth rate that you're seeing, where you make then certain assumptions about the data, how you think the market will develop. You will probably pull in some research from certain research institutes. IDC would be one of those. Gartner would be another one to see, okay, how is certain trends developing? And based on that, you would develop a model with which you try to forecast the future by making these assumptions, by saying, okay, we're expecting a growth rate of, let's say, 15%, for example, in a certain market. So we're expecting our sales team to deliver additional 15%, maybe even 20%, by saying like, okay, we believe our salespeople are well educated and they know how to drive things. So we know the overall market is driving by 15%, but we think we can grow our revenue by another 20% or so. So that would be one example of a predictive analytics professional. But if we now look into what data scientists are, and I'm going back to the study here, so data scientists are a subset of these predictive analytics professionals who have the computer science skills necessary to acquire and clean or transform unstructured or continuously streaming data, regardless of its format, size, or source. And here we find what both Dermot and Catherine were just talking about. So we find, to one hand, statistics, of course, because to work with data, we will need mathematics and statistics, because a lot of these models and things are based in there. And on the other hand, we will need some, or at least for a data scientist in the classical sense, we would also have to have someone who has experience in computer science. So, for example, knows how to deal with languages such as Python or R. But he or she will also have to be able to understand and work with data. So they might be able to, or they should be able to deal with structured data. So for example, in form of a relational database system. So for example, data that you can pull out with SQL, or with a non-relational database system, where you would, for example, work with unstructured data in JSON formats. Or you would be working with continuously streaming data. Streaming data you would typically find in, I talked about sensoric earlier, in IoT use case scenarios where you would pull in sensor data, which would deliver maybe every second or every minute, depending on the sensor and what it does. For example, data from a public facility like water pipes or other things, or electricity grid, that would deliver that certain things are happening, and you would have all these data points that it would be constantly streaming in and managed by a system based on which you could do analysis then. That is like one definition. I like when people ask me what do I think is data science, because to some way data science for me is like the rebranding of something that already exists. I would personally call it applied statistics. Because what you typically find people that are doing it on a very, very high level, where you have larger companies with large data science teams, you oftentimes find people with PhDs. I have a lot of customers that work with that have PhDs in physics that are working with that. So you would find your typical computer science, but also STEM degrees, mathematicians, obviously, doing these kind of roles. That being as a data scientist. And if we look a little bit further, here we see the overall professional requirement, or based on those that are calling themselves data scientists, we're compared to regular predictive analytics professionals, that typically we have a relatively high amount, with about like 42% of people actually having a higher education degree, such as a PhD. So coming from a research field, while for the predictive analytics professionals, if you're a BI professional, or you're working as a business analyst or a financial analyst, you oftentimes find that master's degrees are the go-to thing. In both cases, this is a bit more rare for people to just have a bachelor's degree. Part of that probably having to do because you won't have done this advanced mathematics that you will necessarily require to do these kind of things. This is why particularly STEM PhDs, as talked about physics, are quite suitable for that. But this is, of course, this is also part on what companies are wishing for. And what we see is that people oftentimes look for a type of a unicorn. And I will show a graphic a little bit later where we can see that in terms of requirements, what people should be able to do and what they can actually do. Because if we're honest, as a data scientist, you do not only need like the computing experience, that you have an understanding of computer science so you can write code in R and Python, for example. You also probably need to be able to have a couple of other languages I talked. You need to be able to deal with JSON data. You need to do with SQL data. So you need to have experiences in data engineering, or what you would classically call a database admin. So someone that has experience in managing the data, because you will have a large part of the job is actually pre-processing the data. It's not necessarily building the models. Has a certain element, but because data, if it is not classical business data that you, for example, get out of a ERP or CRM system, which is already nicely formatted, you have, for example, customer ID, then you have the customer name, credit card details, what's their buying behavior, and these kind of things. Now, you will deal with all types of data that you're also trying to mash together. Particularly then when the streaming data, so live data coming in, that needs to be correlated and put together at some parts with historical data. So you need to do all of these things with the data itself. So you have to have vast experience in that. And then on top of that, you will also have to be able to interpret all this data, because this data will always be seen in some form of a context. You can't, and I will show you later on in the hands-on part, where this can become problematic, because just applying certain mathematical operations or statistical models to data can lead to results, and they say something, but they in reality might actually not say anything, because just obviously it will work. It's in the end, it's numbers. If you apply operations to a number, you will get a result, but this result needs to be interpreted in the context of the analysis, in the context of reality, because you might be completely off, but the model has told you, oh no, there is something. For example, correlation between two things that have nothing to do with each other, that are actually not caused by each other. And there, my old statistics professor doing my bachelor's used to say, it's like, keep in mind this one sentence if you learn nothing else in statistics: correlation is not causation. So I'm talking about this unicorn and this difficulty of actually necessarily finding people. We'll go a little bit in detail into this. This is where, for me, the citizen data scientists come in. What these are is, if you take it in German, it would be what I would describe as a classical Quereinsteiger. In English, you would say career changer, but I think Quereinsteiger has a bit of a different connotation in German than career changer has in English. So these are people that maybe don't have the classical, because maybe they lack the computing experience. Maybe they're social scientists, but they have some statistical experience, because we don't forget, if, for example, someone studies psychology or economics, those can be quite heavy in statistics as well, without necessarily having to learn programming languages or do certain other things. But you can also keep in mind a subject matter expert who knows a certain industry very, very well. If you, for example, work in the food industry with its own requirements and certain things, because you regularly receive from your suppliers different badges of different kinds of resources, so raw foods, for example, this will all give you an edge, because you need all of these parts. And yes, you might not do all levels to everything. So you might not be able to go into the database and do the data meshing yourself, or you will have to rely on that someone is pre-processing the data a little bit for you, or that you're working with certain pre-processed data. And you don't necessarily do the research heavy part where you develop a new model or trying to come up with things, so you don't go into what's currently in the research and trying to pull out the newest points for that. Basically, what you would be doing is applying different tools with certain methodologies in mind, and certain concepts, for example, that you need in statistics, for example, that data that it can be properly interpreted should be following a normal distribution curve. So things that can be relatively easily checked and be taught to someone without having to know all the other things. Because in the end, and this is what we will see here, it will be very, very, very difficult to actually get this unicorn of someone that can do everything. And that has this high level of overview on all of these things, plus, for example, a PhD. Because if we just look, and I forgot to put the percentage on that, let's actually do that quickly. Where's my calculator? So we have 28,000. So this is for the year 2019, 6,000 people graduated with a PhD, independent of what their actual degree was, 8.5. So this is 0.05%. No, it's 5%. 5% of all graduates in Germany in 2019 did do a PhD. And out of those 5%, obviously a smaller subset will have a PhD in an area that can be directly applicable. So for example, mathematics or econometrics, statistics, or even in data science. That's of course possible as well. So we have, if we just look exclusively at German numbers, and you will find a similar thing across other countries, it will be very, very difficult to just find this person that can do all of that. And this is the graphic I was talking earlier about. So in terms of what data science is and what we want to achieve, some of these things, and this is my argument for the citizen data scientist, because domain expertise, you can bring along because you've been working for a long time in the industry. The computer science part, if you really want to, so the learning of Python or R, they are relatively accessible languages. You can continue learning that, but you don't need to. And I will show you with Azure Machine Learning Designer that you do not need this. You can do this with no coding experience. You can do your own model deployment and then work with that. The same part with mathematics. You do not need to be completely proficient in everything that's going on there, because in terms of statistics, there's, I would argue, a handful of things. One I talked about, for example, that the data should be normally distributed, which some of these things actually with size of the data, so the amount of data that you have, become less relevant. It's important to check for it anyway, but just to make sure you can receive results with that, and you don't need to have long training in all of this, because these are things that you can look up in a statistics book that will tell you, oh, you should look for this, 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 and this, and there will be 5-6 factors. Kurtosis, so if data is skewed to the left or to the right instead of normal distributed, for example, is such a factor. And once you have that, you can almost have a checklist and just work with that. And you still will be able to do all of this based on, for example, Azure Machine Learning. So coming to that, let's switch over to Azure Machine Learning. Where is my Azure portal? Here it is. So I have something deployed in the background, but I wanted to do it like going live through with you how you would do it. So my Azure resource group here, I will go through this quickly, just in case you haven't seen it, you can ask me questions afterwards. So basically what I'm doing, I'm just deploying an Azure Machine Learning instance in my resource group that I've created in advance, so just as a logical unit. It will ask me a couple of things. So I will call this hands-on 21. I will deploy this in the Dublin data center because it's the closest one to me. Storage accounts, I can choose selective things here in Azure. So if I have already a storage account, I have a couple of them here, I can use those. I just put in new things and let everything as it is. Container registry is not that important for the beginning.
Sorry, Henry.
Yeah, go ahead, please.
I just see a blue screen with Azure Machine Learning and nothing else. Is it a problem I have only?
No, I have it too.
Good that you're bringing this up.
Okay. Seems to be a statistically significant number.
Here we go. Can you see it now?
Yes.
Yes. Thank you very much.
Okay, fantastic. I wonder what that was. Okay, thank you, Thomas. So yeah, so I will go back because some people didn't see it. Sorry about that. So this is our Azure portal. For those of you that are not familiar with, if you sign into Azure, you make your own account. I can show you later how to do that. You will end up in this portal. All I did in advance is I deployed a resource group. This is just a logical unit so that I know what I have there, and I can delete it afterwards, so it doesn't cost too much cost. And in this resource group, I'm now just going to deploy an Azure Machine Learning service by just clicking here, Machine Learning, and doing that. So workspace name, Azure Global. So I just have to give it a name. Our region is North Europe. That's a Dublin data center because it's the closest one to me. Here I can choose things if I already work with key vaults and storage accounts that I have that I want to choose. I can select them here. I just work with everything new. I will just go on review and create. So that's going to take now a moment to deploy this. It was important to me that I wanted to walk you through with all the steps. So for those of you that are already familiar, that's sorry about that, but some people might not be familiar on how all of this works. And since this was intended as like showing on how to do this yourself relatively quickly, because you could, for example, use the free Azure services that you get for 12 months if you sign up with the portal to do something like this. So we let this quickly deploy. I can show you in the background. I have another resource group where I was doing some testing. Here I've already deployed it, and what you can see, certain things that were deployed, a storage account, because of course I had saved things. There's a container registry as well as an application tool, because I was deploying a machine learning code here that can be tested and afterwards and be consumed. So perfect, my deployment is finished. So if we go to the resource, and we can launch our studio. So in Azure Machine Learning, so there's Azure Machine Learning and there's Azure Machine Learning Studio. So Azure Machine Learning Studio is, I think it's called Classic, in brackets after that. It's like sort of the old version with this. It also works. If you want to work with the new one, you can use this one here. So what is now Azure Machine Learning Studio? Well, basically this is your environment to do any kinds of experiments, track your experiments, publish the experiments, and generally work with them. There's multiple ways of what you can do. So for example, there's the possibility of deploying notebooks. I will just quickly show it here. These will be Jupyter notebooks. So you have your own Jupyter editor here. So Jupyter notebooks can be used, I don't have a compute instance connected, to work with Python or R. I can write my Python or R code, import my different libraries that I want to work with, and I can write the code and run my experiments from here. So that would be the way of doing that. Then there's an option to do automated machine learning runs. We will ignore those for the moment. And then there is the Azure Machine Learning Designer. So this is basically the graphical user interface with a couple of examples already built in, which is really nice. I will show you where to find them. And we will use not one of those pre-made examples, but one that I thought of with a data set that I knew before. And using drag. Yes. Sorry
to ask. It might be just me. Could you maybe zoom up your browser, because my eyesight is a bit crap? Thanks. Of course.
But is that better?
That's probably too big for most people, but that's great. Yeah. Thanks.
Okay, wonderful. No problem. So this is what we're going to be using. But the first thing that we're going to be doing is actually we need to deploy some compute instance, because we need computing in the background. So we have multiple options of things that we can do. We can deploy single compute instances. What we will deploy to use is a compute cluster, because it's actually a very nice thing to do, particularly if you're an Azure administrator and you want to enable, for example, your marketing or sales department, so those that could be working with models, for example, to build their own forecast, you would still have a certain control of cost over this here. We have a couple of options what we can do. So we have a dedicated compute instance, low priority, I would not recommend. Then the virtual machine type, we have the choice between CPU and GPU. So GPU for the graphical capabilities if you need very work-heavy workloads. For our example, CPU is perfectly fine. And he can either recommend some options and just show those, or we can select from all of them. We'll just work for now with the selected options. The location, as you can see, cannot be changed. This is due to where I deployed all of this, because if you remember here, I had deployed my Machine Learning Studio in North Europe. So I will only be able to use the things available in the Dublin data center. So we'll give this a name, hands on Global Azure. And we make it easy. So that's the compute name. And as we can see here, he has already pre-selected a DS3 V2 instance. We've put an available quota of 98 cores if I really need to, and a certain gigabyte cost available with that. And what I can do here is I can define a range of nodes. which is a very nice thing to do because it can obviously set the minimum number of nodes to 0 and then set a certain idle time before it scales down. So it will basically, from a cost perspective, only run when I actually run my models and not constantly degenerate costs. Which is a good thing to do. So we could, for example, put this higher or lower, and we have of course increased the number of nodes. I will just put them on 6, for example. You can do SSH access if you wanted to access the nodes directly, and you have a couple of advanced settings that I will ignore for now, but there's a couple more things you could do with it. So what will happen now is we don't need to give feedback. This will be creating in the back. What we will do a couple of other things while we're waiting for this. So we will be creating or uploading a data set. So there is a data set monitor with which you can look at the different data sets that you might be working with. But what we need is we need to upload from local files one of our data. So we need to choose the data type. It's a tabular file. Its data set name is hands-on Azure. It's housing data. Because that was publicly available. Of course, ideally you would want to work, for example, with marketing data that you pull off your e-commerce store. If you wanted to, for example, build a predictor how likely one of your customers is to buy things based on previous behavior, you could do that, for example. The problem with this kind of data is it's typically not publicly available. So what you will find is housing data, economical data. There's certain companies that offer actually data as a service that will provide you with, for example, market research, but those are paid for programs. I have none of those, so I would just work with the data set that I had. We work with the previously created blob store. I can create a new one. I can change one. We're just going to upload our file. It's this one. It's a CSV file. And we do OK. So he's now going to be checking the data. That's all fit. We get a little preview of what we have. So as we can see at the moment, he doesn't recognize that we have column headers. So we're going to tell him that we have column headers, and he will adjust that in the preview. So now we see we have house prices, we have the size. I think this is US data, so this should be in, what is it? It's not in square meters or square kilometers. What's the US using? Well, their system. Sorry about that. We have the age of the house. We have the value of the land the house is sitting on. We do have the living area size. We do have the percentage of college education that is living in this area. We do have the number of bedrooms, the number of fireplaces. We have the number of bathrooms. For those of you that are surprised, 0.5 here signifies that it's basically just, instead of a classical full bathroom with shower and everything, it's just a toilet. We have the amount of rooms. We have the different type of heating systems deployed with the fuel they are using, the sewer tank system that they have, if it's either a septic tank in the backyard or if it's a public connection. If someone, and a couple of fails true things, if it's a waterfront property, if it's a new construction, if it has central air condition, for example. So we can give encoding, which type of it is. We have the delimiter for comma. If we, for example, put it on space, we'll see that he changes how he recognizes things. So he would give us that. So obviously this is not what we want for the data set. It's a comma delimiter, and then we get back to what we want to see, because the Excel spreadsheet looks exactly like this as well. So, and we could choose to skip certain rows. Don't want to do that either. Okay, then I have the schema selection. So it shows me how it recognizes the different factors that are in the, and I will zoom out a little bit. Here we go. I can see that, that we have in the data set. So for example, we have the price, which is always an integer. So we don't have any comma positions. We have decimals, we have integers, and we can double check here that every of this is correct. So college percentage, yes, integer. We have Boolean, decimal, string, and date if we wanted to do that. So we could, in case he wouldn't recognize this correctly, we could correct this and telling him this is the type of it. For example, the waterfront he clearly recognizes as a Boolean, while the sewer, fuel, and heating type he recognizes as a string of different things that are being offered there. And we can also choose to include or exclude certain variables if we wanted to do that here already. So, okay, then he gives me the overview of what's going to be there, and please create this data set. Okay, so now we have our data set uploaded. And what we need to do now is we're going to our designer, and we're going to build a new model. So and what we're getting is this canvas area. So what we want to start with is we want to select a compute target. This is the cluster that we just created. So we're selecting this, so where our compute parameters are going to be executed will be happening here. Obviously, you can have different ones. So if you want to create multiple of them, they will all be showed here. You can even create a new one from here with certain things and settings. So what we need now is to put our data set in here. And then we want to do things with the data set. So the first thing we want to do is, because what we want to run, what I want to achieve is, and I will show a little bit of slides and some drawing on that while this is running, because this will take a little time. We want to select certain columns in the data set. We do all of this drag and drop by connecting this. And this will be, because what we want to do is we want to build a model that forecasts, if we go, can actually do, wait a second. No, where is it? Data. What's it called again? Show data. Please forget. Sorry about that. Give me a second. I have it open in the back. So we will work with that. So what we wanted to do is visualize data. Didn't I look for that? So much for doing that. So these are the example data sets, by the way, that Microsoft provides. We have IMDb movie titles, we have movie ratings, we have CRM data if you wanted to work with that, so you can try out all of that. And now, by the life of me, I can't recall how this feature is called. Don't want model evaluation.
Is it feature selection, Henry? You're at the early stages of the pipeline.
No, I was just wanted to show that because you can show the data set. You can show it here, but there is another feature that can do that, and I forgot how it's called. It's fine. I will look it up later and show it. Basically, it will give you the first parameters of the data set. This just shows you the data set as it's being pulled in with a couple of graphs. But then there's also another one where you can show some of these factors a little bit more in detail. But what you can do here, you get a clear or a first overview on the data set and how the data is behaving. So for example, what we see here, which is something that we should consider, we will not for the sample of this model, but we see that there's a certain skewness, for example, in the price. So this would be something that we would have to address under normal circumstances, because this is clearly indicating that it's not a full normal distribution. So from a statistical perspective, it's a little bit iffy. So you would do a data transformation on this. To move this to a bit more normal curve behavior, normal curve being this classical bell shape that you're probably familiar with, as well as with some of the other things. So you would want to look at that to make sure that there is no particular problem in this. And you can do this by checking here. There is a way of checking for outliers as well. So all the data pre-processing, basically what we're skipping right now, is one of the things that you can do in here as well. So I just wanted to show that, but and you can also, of course, check, okay, is everything here? Is there any missing value types? That could be something important. So you can click through the individual things. It checks, is there a missing value? The data set does not have any missing values, but if there is missing values in it, you could, for example, clean missing data. So there's an extra one. We don't need this for this data set, but you could define based on a specific column. If we were to pull this in here and we were to say, okay, please go with, for example, column price. If we know there's missing data in there, we could tell it what to do with it. So we could, for example, remove the entire row if we have a very large data set. We could substitute the value with something. We could replace it with the mean or median or the mode if we think that that would do it based on our statistical assumption beforehand, and can do a couple of things just to work with the data here. So you wouldn't have to do the pre-processing necessarily in Excel, for example, which you could do. So what we want to do here first is select our columns. So we're going to want to run, we could run an analysis across all of this. We won't do this because since I know the data set, there is a certain correlation, and you can think about that the higher the correlation between different factors it is, the less likely you want them in the model. Because if you just throw in everything, the application will work, but what you want to try, you want to find the best model with the best fit for the regression that you're running on it. And what we definitely need is the price, because we want to forecast the price. Lot size and age certainly has a factor in the price of a house. The land value does. The living area probably as well, percentage of college to be debated, but yes. And then we have, for example, bedrooms, fireplaces, and bathrooms. Those are factors that are definitely will be strongly, and I know because I know the data set, so they will be strongly correlated with the lot size and the size of the house overall. Because of course, the more space you have, the larger the house is, the more bedrooms you will have, the same as the more rooms you will have. So those are factors that for this scenario, I will exclude. You could throw them all in, and I will show you at the end. We won't have enough time to do that. You could run, and you should, multiple models, because you want to try to find the best model and compare these different models based on different factors that you've chosen here. So we're going to throw in heating, the fuel, the sewer system, waterfront you will probably find in the land value, so I will ignore that as well, because if it's a waterfront property, the land value will most likely be higher. We have a new construction that will make a difference, and does this thing have air conditioning? So what will be happening is that there will be a column to be selected. So it just reduces our data set by the model, by the columns that we have excluded here. And then what we will be doing, the next thing is we will do split data. Because what we want to do is we want to have data with which we can train the model. So the model is being based on, and then we'll want to have some data that we run the model against with. So some data that hasn't been used for testing to check how accurate our model is. That's what we want to find out in the end. So, and what we can do here is we have a couple of different options how to split this. I will just be splitting this by rows. And you can give it a factor from 0 to 1. Smaller than 0, like larger than 0 and smaller than 1. So we're going to give it a factor of 0.8. So 0.8 of the data will be used, so that's the left side, will be used to train the model. And 0.2 of the data will be used to evaluate the model in a later step. What we then need is a linear regression. This is one of the operators that you can do. You find them, I do believe, under machine learning algorithms here. So there is a number of different algorithms, for example, for classification. You can have different models that are already being there, multi-class neural networks. You have the, where's the regression models? Yeah, linear regression. So you have the regression models under here under regression. So you have a couple of different things that you can choose to work with. You just basically put it in here. And then what you want to do, you need another one, is the train module, which is this one. So, and here now we need two inputs. We need our split data, and we need which type of analysis we want to run with this. And then we want to tell him, okay, which column do we actually want to use? So what's our independent variable? So what we want to forecast? We want to forecast the price of housing. So we're selecting this here. Katrin, how are we looking with time?
You still got 10 minutes left.
Okay, perfect.
But there's 15 minutes break to the next session, so you can take your time.
That's okay. I will show, since I have another window open where I did all of this before, and I will show some of the things there because I was concerned that the time might not be enough to show everything. So we train the model. We're training it to look for the price. And then what we want to do is we want to score the model to allow to check how good our model is. So it will score all of this. And here is where we basically pull in the split data to make sure, because here is what's happening. Here's the comparison between the data. So the 80% of the data that we've used to build our model and the 20% of the data that we use to test our model. So, and then the last thing we need is an evaluate. It's this one. We can scroll out a little bit here so you can see it a bit better. So we're just going to plug it in here. And what's going to happen is this will evaluate the model and give you some statistical results at the end of it. So all we now need to do for this to run is basically to submit it to our compute cluster. It will ask me to set up a pipeline and name it, to name the experiment. So we then name this Azure Global Test 1. And what it's doing now, it's going to be starting the cluster up in the background. You can see that here, and it will run through all of these steps. This will take a little while, so we'll briefly go back to the presentation. Let's see if this runs through in the 10 minutes. It should be. If not, as I said, I have it here, and I can show briefly here. It's the same thing. I built this earlier this morning to make sure that we have something prepared. Is what do we actually do? So I quickly wanted to talk about what we're doing here in terms of a linear regression. So basically what we're trying to do, or what we're doing with the linear regression, is on a multi-dimensional plane, we're trying to find the most optimal way to traverse this plane. So this looks very complicated in the graphic if you're not familiar with it. So if I simplify that a little bit, I'm just going to switch to my other screen, the whiteboard. So number 1, screen number 2, my whiteboard. Where is my whiteboard? There's my whiteboard. So basically from a mathematical perspective, all that we're wanting to do, or that we're doing with the linear regression model, is that we're building a formula and then that the computer is basically building for us at the moment, based where we have a formula F, which has certain properties with certain values. So we have a so-called intercept, let's call that factor alpha. That is basically if we have a two-dimensional model, what we have, and we have a lot of different data points in a cloud, and then our simple linear regression is just this this line that basically minimizes the distance to all the different points. And the intercept, so this factor alpha would be the point here where it cuts into the y-axis, while this is our x-axis. Obviously, in a multi-dimensional model, this is a bit more complex what it is, but there's still, because there's more, so you have not only a z-axis, but you have like a lot of axes. But what this is where it basically cuts that axis. And then we have, for every factor, we have, if we build this for our house pricing model, let's make it concrete directly. So we have our housing price that we're looking to forecast, housing price. We have a certain intercept alpha. And then we have a factor beta, 1. That is multiplied with, if you remember, the columns that we selected in the other model. I just want to open this up that I named this correctly. So the columns that we selected were lot size. So we have the lot size, because this is how we're going to predict all of that. And what the model does is to figure out the beta values for us, to tell us how do we need to, what do we need to multiply the lot size with, what do we need to multiply the h with, beta 2 times h, beta 3 for our, what do we have, land value, times the land value, and basically so on for all the factors, depending on how complex or less complex we want to do, plus in the end, an error term. I forgot which sign this is. Let's give it gamma, an error term that we have. And what our model is now doing is trying to figure, or is working on figuring out this formula for us, so that in the end, we will have not only an indication how well this model is working, but also we could plug in all these values based on another house, for example, that we have, for example, in the same region, and then tell the model, please predict the house price based on the lot size, the age of the house, how much is this house worth, or how much compared to the other prices would this price be. That's basically what we want to achieve. And this is what we see within this multidimensional space, where we have just what we have in the simple model here, in the simple linear regression with just two factors, and a multidimensional space where our information points are across multiple spaces. So our model is still running. So I will go back to the other one that I've already prepared to show you the outcome here, as you can see. So this is now telling me when it is completed. So this one has completed, the next ones are running. This, depending on which kind of compute resources you're having in the background, because this is a smaller machine, takes a little while longer. But we have here, I have the pre-processed one. This is basically the same thing. So what we're going to get is, if we visualize our score model, it will tell us for each value the price based on the factors we have put in. So the original price is $260,000 in the data set. And the price that was predicted by the model is $233,000. The same is for the second one, $174,000, and the prediction value is $218,000. So we see, okay, the model is off. We can check the last one, 191,500. 260,878. So we see already with some of the values, the model is quite off. Obviously, it's just an approximation of what it is. And if we now go into the evaluate model part, we can do view the output. And if we, oops, that was the wrong output. I wanted to have visualize. If we visualize our results, what it will tell us is a couple of different statistical measures. The important one is this one, the coefficient of determination, also called R-square. This basically tells us how good our model is. It's a value between 0 and 1. The closer the value to 1 is, so the closer R squared is to 1, the better our model performs. So as we can see now, okay, this alone doesn't tell much. It says, okay, the model is, it doesn't mean that the model is 61% of the time correct, but we have a good model. What we would want to do now, because we want to drive R square as high as possible from a statistical perspective, is we would build a different model with the same data set, but potentially different columns selected. So for example, we could, here in the score evaluate model, you see there's a second input. We could build a second pipeline from the same data set with the same column data, with different column data by just going select. I'll just show you briefly. Select column. Oops. So we can just draw this in here and pull this over. Oops. So pull this over here and would just this time select different columns. So for example, we would, if we go by name, price, we obviously have to increase. We could, for example, add all. So we could do this. Then we would do the same. I won't do this for the sake of time. We would split the data again. We would run another linear regression model. We would train it all on the side of here. We would score the model. And then finally, the scored model, we would put in the other side of the evaluate model here. And then it would, for us, compare the two models with each other. So it would tell us which of the two models predicts the actual value of the house price better. And we would have to, and this is basically where the art to some extent comes in, is we would have to do that for as many possible combinations of factors as we could think of. The reason here why you don't want to do this for all of them, you could do this, it would just take forever. There's even in R, you could run a statistical model that compares all of them by adding the different values and then subtracts them. This is basically where your subject matter expertise would come in. What I talked about when I selected the columns here, certain columns are probably correlated with each other. So for example, lot size, number of bedrooms, number of fireplaces, and so on. If they are already correlated, that probably means that they won't have that much of an impact, because already the major impact is in one of the large ones, typically the lot size, because all the other ones, bedrooms will be correlated to that, fireplaces will be correlated to that, and they actually are in this data set. And you could do this with a correlation matrix if you wanted to. You could compare that and based on that make a selection of factors and then have limited amount of models that you would compare to each other. Okay, this is basically how you very quickly build your own, and this one, oh, it's almost done, perfect. So it took about a couple of minutes. How you would build your own data pipeline to have your own first model. And what you can do then is you can deploy and publish this model. I've done that already, so by just clicking on this button here, you have the possibility to deploy your model. So what you will get is you will get a REST endpoint with keys and other things where you can basically decide if you, for example, want to use an application where you can put the data in a simple mobile application. For example, you can use the primary and secondary key to address this REST endpoint and give it data. And then the model would run in the back and would tell you a result of the price. Why is this still deploying? I had hoped I could show that. Ah, yeah, okay. Perfect. So I can't show you because my model didn't deploy. I can't tell you why. Normally under the test feature here, basically it would show you, it would ask you for the factors that we have put in. So in the case of this model, the factors that we would have to put in, if we go into, oops, that's the wrong one, on the visualize, is lot size, age, land value, living area, and then the different heating values. So we would give these information into the model, and then the model would tell us what the house price would be. And that's all that it takes. So very straightforward. The devil is in the detail, and one has to consider some statistical things. But as I said, I think it's 5 or 6 factors you would have to consider, and you could just check how to, and if you know how to deal with them, for example, what we had here with the skewed house price, you could easily apply a log to this, and that would get rid of the skewness, and you would have more normalized data. You could even use a function that's already built in, which is called normalized data. So you could pull this into the system based on what kind of transformation method you want to use, would do it for you based on certain columns. So you could easily plug this in here. Yeah, just briefly, I talked about already correlation is not causation. These are all mathematical models. I can literally throw everything in there. And it, as we see here, a little bit humorous, can lead to misinterpretation, and quite heavily so what's happening. So one always has to, when working with the data and doing these analysis, it's always worth at the end when one has a result to go back and see and discuss it with other people as well. Does this actually make sense, what we've done here? Because you can correlate literally anything with everything. And that would result into some form of result, for example, the total cancer case with cell phone users. And then, well, the result being, okay, cancer causes cell phones, which is, of course, nonsensical. But this is where the interpretation part, and once again, the subject matter knowledge comes in, because you have to put the data and the result of the data into some context. Yeah, these are my sources. I can share the slide deck. I'm sure we can do that, Catherine, if you want to have a look yourself. All that remains to say from my side is thanks very much, guys, and be curious and have fun. Go try it out. There's a link down. You can use Azure for free for 12 months, or you use a company account if you have that. It's great fun. Don't worry about it if you're doing something wrong. When I built this, some of the things weren't working correctly, so I had to look up multiple times in the documentation to check something. Sometimes I just, one time I actually just had to reload everything. I don't know why it didn't run, but the pipeline, I didn't change anything. So there is a little bit of hiccup here and there, but overall, that's going to be it. That's Azure Machine Learning and Citizen Data Science for you. And we can do a couple of questions, I think, Catherine. if there are any.